This is Dr. D. Govardhan, Professor in Ed, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the topic is problem solving on resultant of a force system. The resolution of a force. The process of splitting a given force into number of components without changing its effect on a body is called resolution of force. The force can be resolved into number of components having include angle 0 to 90 degrees. But if the inclination between the two components, if it is equal to 90 degrees, the type of components are called rectangular components. Generally, the body is resolved into rectangular components to find the resultant of the forces. The resolution of force, it is generally treated as reverse process of addition of forces. The principle of resolutions. It states that the algebraic sum of the resolved parts of number of forces in a given direction is equal to the resolved part of the resultant in the same directions. In general, the forces are resolved into two components in vertical direction as well as in horizontal directions. So, in the process of finding the resultant force, first resolve all the forces into two rectangular components. Preferably, one is along the horizontal directions and another one is in vertical directions. And add sum of all the component of forces which are acting along the horizontal directions is treated as sigma h. Generally, it is equal to the resultant force component along the horizontal directions. Similarly, resolve all the forces in vertical directions. Find the algebraic sum of all the components which are acting in vertical directions. This algebraic sum is treated as the component of resultant force in the vertical directions. The resultant R of the given forces will be given by the equations. R is equal to R square is equal to sigma h whole square plus sigma v whole square, or resultant is equal to under root of sigma h whole square plus sigma v whole square. The direction of the resultant force can be determined as let theta be the inclination made by the resultant force measured with respect to the horizontal line, that is the x direction, and measured in counterclockwise directions. Then tan theta is equal to sigma v divided by sigma h, where sigma v stands for the algebraic sum of the vertical component. Sigma h is the algebraic sum of the horizontal component of the forces. Now, if the values of theta will vary depending upon the values of sigma v and sigma h as discussed now. Now, when both the sigma v and sigma h are positive, that means the x component, y component both are treated as according to the coordinate system. First coordinate, second coordinate, third coordinate and fourth coordinate. If both the sigma h and sigma v positive, that means the resultant force makes an inclination between 0 to 90 degrees. But when the sigma is negative and sigma h is positive, that means the resultant force belongs to fourth quadrant. That means it lies between 180 to 360 degrees now. Similarly, when sigma h is a positive and sigma v is also positive, it belongs to 90 to 180 degrees, and sigma v is negative and sigma h is also negative. That lies between, this lies in third quadrant, and inclination lies between 180 to 270 degrees. That means the resultant force inclinations depends upon the algebraic values of the vertical component as well as the horizontal component of the resultant force. Here in this problem, we are considering four forces F1, F2, F3 and F4 acting at a point as shown in figure now. In this figure, the F1 is making an angle of theta 1 measured in counterclockwise directions with x-axis theta 1, F2 theta 2 with the x-axis, and F3 theta 3 and F4 theta 4 with the x-axis we are taking. Now, in order to find the resultant of these forces, first resolve the force into components, preferably along the x direction and y direction. Now, if I take this F1 is making an angle of theta 1 in the figure 2.14, when it is resolved into two components, one is the theta along the x directions. First start with the x now and the y directions. This is the way of resolving the force into two components now. Now, the x component is pointing toward the left hand side and y component is pointing toward the upper directions. According to the conventional system, the forces, the horizontal component of forces which are acting along the x directions are treated as positive. The component of forces which are acting along the y direction are treated as negative direction. Similarly, F2 is there now. Again, when we resolve the forces into two components now, horizontal component is moving toward the left hand side and the vertical component is moving upward directions. That is, the horizontal component is treated as negative, which is equal to here now F2 cos 2 theta, but it is acting toward the left hand side, it is treated as negative. Y component is F2 sin theta is acting upward directions. Similarly, F3 is there now. While drawing the component of forces, one is along the x direction and y directions. The horizontal component of force is acting toward the left hand side. The vertical component is acting downward direction is treated as a negative now. Similarly, F3, F4 is there now. When it is resolve the forces into two components, horizontal component is acting toward the right hand side and the vertical component is acting in downward directions. Now, according to the convention, the forces which are acting toward the right hand side is treated as positive, toward the left side is treated as a negative. Similarly, the vertical components which are acting upward directions are treated as positive and downward direction are treated as a negative direction. Then according to the procedure for finding resultant component of resultant force, it is equal to Rx is equal to, that is the component of resultant force acting along the x direction is equal to algebraic sum of the component of forces acting along the x directions. So, F1 it is there, the horizontal component is treated as F1 cos theta positive minus F2 cos theta because it is acting toward the left hand side minus of F3 cos theta 3. Similarly, plus F4 cos theta 4 now. Similarly, the component of resultant force acting upward directions, F1 component is positive, F2 component is also positive, F3 component is negative, and F4 component is also negative now. So that means the vertical component is F1 sin theta 1 plus F2 sin theta 2 minus of F3 sin theta 3 minus of F4 sin theta 4. Okay, this is the procedure that is generally followed to find the component of resultant force along the x direction and y direction. The inclination of the resultant force with the x direction is given by, if theta is the inclination made by the resultant force with respect to the x axis, then theta is equal to sigma fy divided by sigma fx. Okay, depending on the values of algebraic values of sigma fx and sigma fy, we can determine the resultant force which is acting in which coordinate now. That is the first coordinate, second or third or fourth now. Now, based on these principles, that procedure, we can find the resultant of several forces are acting on a body. Now, in this problem, I am taking a system of forces acting on the corners of a rectangular block as shown in figure. Determine the magnitude and direction of the resultant force. Here the rectangle is represented here now. Assume A, B, C and D now. Four forces are acting on it as shown in figure. At A vertically downward force of 50 kilonewton is acting. At B, 25 kilonewton force is acting toward the left hand side, toward the right side, that is at theta positive. And at C, downward 35 kilonewton force is acting, that is at theta is negative. And at D, left hand side 20 kilonewton force is acting now. So in order to find the resultant of these four forces, first resolve the forces along the x direction as well as the y direction. Since these forces are acting along the x direction as well as the y direction only, hence the algebraic sum of the forces which are acting along the x direction, that is equal to sigma h, which is equal to the horizontal component of resultant force of all these forces now. So sigma h is equal to, here 25 is the positive and 20 is the negative. That algebraic sum is 25 minus 20, which is equal to 5 kilonewtons. This 5 kilonewtons is the horizontal component of the resultant force now. Similarly, after resolving the forces in vertical directions, at A, 50 kilonewton acting downward directions. At C also, 35 kilonewton force is acting downward directions. The sum of the vertical component is equal to minus 50 and minus 35, which is equal to minus of 85 kilonewtons. So the magnitude of the resultant force is equal to R is equal to under root of sigma h whole square plus sigma v whole square, which is equal to under root of 5 whole square plus minus of 85 whole square. Now, on doing the calculations, we got the resultant force is equal to 85.15 kilonewtons. This is the answer. Now, the inclination of the resultant force with the x-axis, it is obtained if theta is representing the inclination of the resultant force, then which is equal to tan inverse of sigma f v divided by sigma f h now. So here, this force is sigma h is in the positive, sigma v is negative. That means the resultant force is lies in fourth quadrant. That means the inclination lies between 182, lies between 270 to 360 degrees and measured with respect to the x-axis. Now, according to these problems, if theta is representing the resultant force makes with the horizontal, then tan theta is equal to sigma v by sigma h, which is equal to minus 85 divided by 5, which is equal to 86 degrees now, 86.6 degrees. This 86.6 degrees, if you take the four coordinates like this now, it is making an angle like this, resultant force, that is, this is the treatment of the theta now. That is, the theta is making with the horizontal at an angle of 86.6 degrees. So, the total generally, the inclination of the resultant force is measured in counterclockwise directions. Hence, this total degrees is nothing but equal to, this angle is equal to 360 minus 86.6, which is equal to 273.4 degrees. This is our required answer now. Now, the second problem, the forces 20 newtons, 30 newtons, 40 newtons, 50 newtons and 60 newtons, that is totally 5 forces are acting at one of the angular points of a rectangular pentagon now, and toward the other 5 angular points taken in order. Find the magnitude and direction of the resultant force of a given forces shown in figure now. So totally these 5 forces are there now. One is 20, 30, 40, 50 and 60 now. These forces are acting at one of the corner, that is assumed as A point, and passing through these 5 vertices of the pentagon now. That means the remaining 5 means nothing but B, C, D, E and F now. So according to the problems, that is one is passing through the point A and B, which is equal to 20 newtons. One more is the AC 30 degrees, 30 newtons, and AD 40 newtons, AE 50 newtons, and AF 60 newtons. Here we are taking the angle measured in counterclockwise directions. So the first force is making 0 degrees now, that is 20 newtons, which is making. The second force, which is equal to AC, it is making 30 degrees with the horizontal. And F3 force, assume 40 newtons, which is making an angle of 60 degrees with the horizontal. Similarly, 4 forces is there now, fourth force, that is 50 newtons, it is making an angle of 90 degrees. And fifth force, 60 newtons, which is making an angle of 120 degrees with the positive x-axis as shown in figure now. So we can measure this, we can resolve this component, we can resolve these forces into rectangular components like this. For the first force, there is no vertical component, only horizontal component is having, which is equal to 20 newton. The second one is, we can resolve into two components like this now. That is, one is horizontal like this, and second one is vertical directions now. Similarly, the third force F3, it is having 40 newtons, making an angle of 60 degrees. It can be resolved into two components again. One is acting toward the right hand side positive, vertical component is acting upward directions. The fourth force, 50 newtons, it is acting only in upward directions. Hence, it is having vertical component and not having any horizontal component. Regarding fifth force, 60 newtons, when you are measuring an angle with respect to positive x directions, that angle is treated as 120 degrees. When you result into forces again now, it is having two components now, that is vertical component, horizontal component, like this now. So you can take the remaining angle is 60 degrees like this, otherwise 120 degrees measured in counterclockwise directions. Now, the horizontal component of resultant of these 5 forces is obtained by taking algebraic sum of horizontal component of all the forces which are acting along the x directions. Here, sigma h is equal to 20 into cos 0, because the inclination is equal to 0. The second one is 30 cos 30 degrees. Third one is 40 cos 60. And fourth one, 50 cos 90. And fifth force, you can take it as plus 60 cos 120 degrees when you are measuring in counterclockwise directions, or it can also taken as minus of 60 into cos 60 degrees according to this figure when it is resolved. Now, cos 0 is equal to 1, 30 is equal to 0.86, 60 is equal to again 0.5, 90 is equal to 0, and since it belongs to second quadrant, that cos is negative, hence 60 into 0.5, which is equal to 36.0 newtons. This is the sum of the component of forces which are acting along the x directions. It is also treated as the component of resultant force of these 5 forces which are acting along the x direction now. Similarly, after resolve the forces in vertical directions, these 5 forces after resolving, they are acting in upward direction. So, hence all the components are treated as positive only. Hence, the resultant of the vertical components is equal to, we can take it as 20 sin 0 plus 30 sin 30, 40 sin 60, 50 sin 90, and 61 sin 120. These are all are moving up, swing towards upward directions positive. This sum is treated as the vertical component of the resultant force of 5 forces F1, F2, F3, F4 and F5. Here which is equal to 151.6. Just we got it now. The magnitude of the resultant force is equal to R is equal to under root of sigma h whole square plus sigma v whole square. So which is equal to 36.0 whole square plus 151.6 whole square, which is equal to 155.8 newtons answer. Now the vertical component is 151.6 is a positive. Similarly, the horizontal component is also equal to 36.0, which is also positive. Since x component and y component both are treated as both are positive, hence the resultant force is always lies in the first quadrant. That means from 0 to 90 degrees now. Now the direction of the resultant force. Let theta be the angle made by the resultant force with the horizontal axis, that is the x-axis, in positive directions. The theta is equal to sigma v by sigma h, which is equal to 151.6 divided by 36, which is equal to 86.6 degrees. This is our answer. Since both the sigma v and sigma h are positive, the resultant force lies between 0 to 90 degrees, hence it belongs to first quadrant only now. Now another problem now. The following forces are active at a point O as shown in figure. The first force F1, which is equal to 20 newtons, inclined at 30 degrees toward the north of east. Second force 25 newtons toward the north. And third force 30 newtons towards northwest. And fourth force 35 newtons inclined at 40 degrees toward the south of west. Find the magnitude and direction of the resultant force now. So in this figure now, when you are drawing the coordinate like this, according to the fundamentals of engineering drawing, here it is the origin. Generally, it is treated that is the horizontal component in positive x direction is treated as the east, just up north, west, and south now. Okay, this is the way of representation of the directions now. The first figure is force is given F1, that is 20 newtons. It is inclined to 30 degrees towards north of east now. That means north and east means it is inclined. It lies in the first quadrant only now. That is 30 degrees in first quadrant, making an angle of, it is making a 30 degrees and having magnitude is equal to 20 newtons as shown in figure now. The second one is 25 newtons toward the north means it is in a vertical direction, moving upward directions, it is represented. The third component 30 newtons toward the north of west. The west is nothing but it is the horizontal component toward the left hand side according to the figure, and north means just upward. That means it belongs to second quadrant, making an angle of 45 degrees as shown in figure. Now third force, fourth force 35 newtons inclined at 40 degrees toward the south of west. That is it is the south and west, it is belongs to third quadrant as shown in figure now. So by reading the problem, so first of all identify the direction of forces F1, F2, F3, F4. Okay, according to the given problems, F1 is making an angle of 30 degrees from positive x-axis, and F2 force which is 25 newtons acting vertically upward directions, and F3 30 newtons, it is acting 45 degrees with the negative x-axis, and fourth force which is having 35 newtons making an angle of 40 degrees with the x-axis as shown in figure, which is lies in a third quadrant. Now in order to find the resultant as well as the magnitude of resultant of F1, F2, F3 and F4 forces, first resolve the forces into rectangular components. The first force can be resolved as here y is the point where it is acting, and it can be resolved first to horizontal component and a vertical component as shown in figure now. Similarly, the F2 it is having only vertical component, there is no horizontal component. F3 just first move toward the horizontal line and the vertical lines. This is the way of resolution of the force now. Similarly, fourth force 35 newtons, it is resolved into two components like this, downward direction and negative x direction now. Now the sum of the forces, sum of the component of forces which are acting along the x direction is equal to F1 cos 30 degrees, F2 cos 90 degrees, minus of F3 cos 45 degrees, minus of F4 cos 40 degrees. The sum is treated as the component of resultant of F1, F2, F3 and F4 forces along the x direction. Similarly, the sum of the component of forces which are acting in upward direction, in vertical direction is equal to F1, that is equal to 20 sin 30. The second one is 25 sin 90. Third force F3, that is 30 newtons sin 45. These three are forces positive because they are acting upward directions, minus that is F4 force is equal to 35 newtons which is acting downward direction, so that is minus of 35 into sin 40 degrees. Okay, this is the way of determining the horizontal as well as the vertical component of the resultant forces of four forces F1, F2, F3, F4 shown in figure now. So in the problems, first of all resolving all the forces horizontally, that is along the east and west line, that is treated as x-axis. Sigma h is equal to 20 cos 30 plus 25 cos 90 plus 30 cos 135, or it is equal to minus of 30 45 degrees minus of 35 into cos 40 degrees, which is equal to minus of 30.7 newtons now. Similarly, when the forces are resolved in vertical directions, that means along the north-south line now, sigma v is equal to, that is sum of the component of forces which are acting along the vertical direction is equal to 20 sin 30 positive because it is acting upward directions, 25 sin 90 it is acting upward direction, so we can take it as here now 30 sin 45 degrees now, it is also correct now, and minus of 30 sin 40 degrees now because it is acting downward directions. When you are substituting the values of trigonometric values of sin 30, 90, sin 135 or sin 45 and sin 40 degrees, we got sigma v is equal to 33.7 newtons now. So both are treated as just a positive. Sigma h is the negative and sigma v is the positive. That means it is now belongs to second quadrant. That means the resultant will make an angle which lies between 90 to 180 degrees now. So the magnitude of the resultant force is equal to sigma h whole square plus sigma v whole square under root of hence which is equal to under root of minus 30.7 whole square plus 33.7 whole square, which is equal to 45.6 newtons as shown in figure. If theta is the angle made by the resultant force with the x-axis, that is west and east line, then tan theta is equal to sigma v by sigma h, which is equal to 33.7 divided by minus 30.7, which is equal to minus of 1.098, which is equal to theta is equal to tan inverse of minus of 1.098, which is equal to 47.7 degrees as shown in figure. Since it lies in second quadrant, the resultant force always lies in 90 to 180 degrees. So 180 minus 47.7 degrees is equal to 132.3 degrees as shown in figure. Similarly, this method is called the finding the resultant of several forces by using analytic method. This method is also called resolution of forces to find the resultant force. Similarly, by using graphical method also we can determine the resultant of two forces or more than two forces. That is the treated as system of forces. In the first case, when the two forces are acting at a point, the resultant of the two forces can be determined by using two laws. One is the law of parallelogram of forces. The second one is the law of triangular forces. Okay, by using these two laws, we can determine the resultant of two forces which are acting on a body. When the several forces are acting on a body, graphically it can be determined by using law of polygonal forces. According to the law of polygonal forces, when the several forces are acting on a body, can be represented both in magnitude and direction of a sides of a polygon taken in order. Then the closing side of a polygon give the resultant of all the forces both in magnitude and direction but acting in the opposite order. Okay, by using this laws, we can determine the resultant of two forces and several forces by using graphical method. But generally, the analytic method is preferable to avoid certain errors, human errors, hence it is treated as preferable. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.